So we talked in the past about structure equaling function. So this is kind of where this all works. And granted, this is not the big periodic table, but this periodic table, if you haven't had too much experience with it, I'll kind of give you a crash course in it. But you could see that everything's arranged as to how many electrons it has. So for instance, if you look at hydrogen, it has 1 electron. If you look at helium, it's got 2. If you got lithium, it's 3. And granted, I'm showing you a periodic table that only shows the electrons and the protons and neutrons, and there's no numbers here, and I did it just to sort of give you a really good understanding of what's going on. You'll also notice in my thing, there's something that says first shell, second shell, third shell. That's another way that we arrange the periodic table. The first shell refers to how many electrons could be in that first orbit. And that first orbit can only hold up to 2 electrons. So this gets to be here because I said up to. It doesn't have to be 2. It could be 2 or less. So here's 1, here's 2. Well, once we get to 3, we have to create a second shell, and that's what you're seeing here. 1, 2, 3, we got a second shell. And if you look throughout, there's always a second shell until all of it's occupied. The second shell can only hold up to 8. So for instance, this outer shell can hold 8 electrons, but it only has 1 in lithium. Where over here in neon, this one has 8. So if we were to add another electron to it, we'd have to move that element over to this one, which is sodium, and now we see a third shell. And that one can hold up to 8 as well before we move on and on and on. So what these are important for is because we're going to learn later that electrons really want to be stable. And the more electrons they have in the outer orbit, the more stable they are. So for instance, if you look at neon, it's got 1, 2, 3, 4, 5, 6, 7, 8. It's very stable because it's got 8 electrons in the outer orbit. In total, it has 10 because can you see how it has 8 in this first orbit and 2 in the second? So that would be 10 electrons total, but 8 electrons in that outer orbit. So it's got 10. Where over here, lithium, it's got 3 electrons, 2 in that first orbit, 1 in the second orbit. So it's not as stable. And what it wants to do is it either wants to acquire some electrons to become stable or lose an electron to become stable. And we'll talk more about that because that is going to dictate bonds and how things are held together. And that's going to be a different discussion. What type of bond, and if you've ever gotten into ionic bond and covalent bond and just not known what they're talking about, that's what they're really referring to as the electrons being shared. You can see at the bottom we have the third shell, and you can see if there's one more electron, it just basically goes into the third shell and just keeps going, and you can see that all these elements are arranged based off of that. The other cool thing I wanted to tell you is everything that's in this row is called the noble. These guys are always gases, and they're called noble gases. The reason why they're called noble gases is because they don't really combine with anything else. So they don't link up to another item because they don't really have to worry about their electrons. They're really happy. So what ends up happening is they stay alone or noble by themselves. I almost think of them like nuns. Like nuns don't really hook up with anybody, if you know what I mean. But over here, these guys really need to hook up with somebody because they need to pick up another electron. So hydrogen is going to either want to get one more electron or donate its electron because it doesn't like having just one electron. So that's what's going to come with pairing of these things to become molecules. And we're going to discuss more about that a little bit, but we're really going to hit it home when you get to chemistry. So Bonds are the formation of those reactions where they are going to share electrons or donate electrons, and that's basically what a bond is. And the reaction occurs with the valence electron. And I know that sounds like, oh my god, what is happening? If I go back a slide, valence electron is just a fancy name for outer orbit. So for instance, if somebody asked you on a test, how many valence electrons does carbon have? 1, 2, 3, 4. It's got 4 electrons in its outer orbit, and so it's got 4 valence electrons. How many does it want? It wants to be at 8, so it wants to pick up 4 more to get this outer orbit perfect. Now, if the question, you really have to read the question carefully, because if it says something like, how many electrons does carbon have? Well, now that answer is going to be 6, because it's got 2 in the first orbit, 4 in the second orbit, so that's 6. So for instance, if I said, how many electrons does carbon have total? 6. How many electrons does carbon have in its valence shell or valence electrons? 4. Let's do one. I'm going to let you do one. I'll let you do an easy one so you don't have to count like crazy. Let's do boron. So the first thing I'm going to ask you is, how many electrons does boron have total? And I'm just going to sit and let you think. If you said 5, awesome. If you said 3, you actually were talking about the valence electrons. So if I said, how many valence electrons does boron have? The answer would have been 3. If I said, which I did, how many electrons does boron have total? 5. Let's do one more just to make sure you have it. Let's do oxygen. Oxygen, I want to know how many electrons it has total. If you came up with 8, great. Now I want to ask you how many valence electrons it has. If you came up with 6, great. And you could probably do the math really quickly, because if it had 8 electrons total, and you know that first shell can only hold up to 2, you could minus 2, or you could just sit there and do what I did and count. So valence electrons, like we just said, is just the outermost orbit. That's the one that's going to be the one that's going to help us make those bonds that we were talking about. And the Octet Rule is just another way of saying that electrons in the outer orbit, that's second orbit and on, want to be in a orbit with 8 electrons. So it either wants to do this by either giving electrons away or getting electrons from somebody else, because it wants to have 8 electrons in that outer orbit. And this is the second orbit that we're talking about. The 3 ways it can get to octet, octet is another way of saying 8, is it can gain electrons, so that means it's going to steal them from other things. It can lose electrons and just give them away. Or it can share electrons. So sometimes you will have custody of these electrons, and sometimes I'll have custody of electrons. And that's what that last one is. And based off of what it chooses, they're going to be called different types of bonds. The one side note that I wanted to give you is, remember how that first electron shell only holds 2? So obviously they can't have 8 electrons, so that one's going to do the duet rule. So that means they only want to have 2 electrons in the outer orbit. So I'm going to talk about ion bonds in my next video.